maybe I'll. So I took 567, I started dividing, and this is what I found. 567 is 81 times 7, and then x squared, y squared. The fourth root of 81 is 3, and then 7x squared, y squared. And then here, for the second one, I did 36 times 2, x to the fourth, y. So I should get 6x squared, square root of 2y. And then on number 3, we should get 3x to the second, y to the second, cubed root of 3x squared y. Whew. That was ugly. And then number four, 96, right? Okay, so I got, for this one, I got 16 times 6, x to the fifth, y to the 12th. So that means it's going to be 2x, y to the third, fourth root of 6x. Yeah, that's right. Okay, and number 5, the fourth root of 16 is 2, a to the third. And then we have the fourth root of a to the 12, 13, 14, 15, third, b squared. And number 6 is 4x squared y. And number 7, I think it's 25 times 6, x to the 11th, y to the 4th. So that's going to be 5, x to the 5th, y squared, square root of 6x. Great. And the last one, 32 is 16 times 2, x cubed, y to the 9th. So I should get, let's see, 4x y to the 4th, square root of 2xy. Okay, questions? Okay, so yesterday we did multiplication of square roots. Today we're going to do division. And basically it's the same thing as yesterday, as long as my nth root is the same and b does not equal 0, because remember, can't have a 0 in the denominator. The nth root of a over b equals the nth root of a over the nth root of b, so I can divide them into separate square roots. So that's all that's saying. So it says simplify by taking the roots of the numerator and the denominator, assume all variables represent positive numbers. So I want to take the square root of both of them. So what's the square root of 81 25ths? That should be 9 fifths, because the square root of 81 is 9, the square root of 25 is 5. Okay, that's it. So on number 2, we're going to do a cubed root. Whew. Okay, the cubed root of 27 is 3, and then 3a cubed root of a over 2b. Okay. Oh no. Okay, 64. The cubed root of 64 is 4x squared, and then we have a cubed root of That would be 6 x's, so there'd be 1 left. 216. I want to say it's 6. 6 times 6, clear. 6 times 6 times 6. Yep, okay. So that's 6y squared. Okay, so 3 problems. I'm going to give you just a few minutes. Okay, so what's the square root of 49 over 100? 7/10. Ooh. And the cubed root of 125/8. Oh, does anyone know what the cubed root of 125 is?
5/2.
Huh?
5/2.
5/2, yeah, good. 5/2. Beautiful. Oh, the square root of 121 over t squared. 11 over t. Beautiful. I should actually make it look like an 11. Okay, so simplify by taking the roots of the numerator and denominator. Okay, so we're still, oh, this still, they're letters for you, D, E, and F. I'm like, we're still doing. Okay, here we go. Whew. All right. So I'm just going to say 2 goes into 32. I'm going to simplify this first. 16. That's beautiful. So the fourth root of 16 is 2a over bc squared. Is that right? That's right. That's right. That was easy. Okay. The fifth root of 32 is 2x, and then we have the fifth root of x over y squared and the fifth root of y. Sheesh. Okay. And then, oh, now we're going to sixth roots. Okay, so I've got x, y, sixth root of y squared all over z squared, and the sixth root of z, 12, 13, 14, 15, z cubed. Questions? I'm so sorry. Oh, nice job, JJ. Okay, so this one, it just says divide and if possible simplify. So I can rewrite this. Basically, I'm going to rewrite this as the full square root. So I'm going to say 700x over 7x. And then I'm going to simplify, right? So the x's go away and 7 goes into 700 100 times. So this basically becomes the square root of 100, which equals 10. Done. Questions? Okay. So as long as my root is the same, I can combine them together. So I can get the third root of 189, x to the fifth, y to the seventh over 7x squared y squared, which is going to give me, I don't know, what's 189 divided by 7? 189 divided by 7 is 27. So that's going to give me the cubed root of 27 x cubed y to the fifth. So that should be 3xy cubed root of y squared. Okay. Oh, this is an interesting one. Okay, so let's see if I can do this. So I've got 1/5, the square root of 100 AB all over 2. 2 goes into 150 times. So that gives me the square root of 25 times 2 times A times B all over 5, which is 5 square root of 2AB all over 5, or the square root of 2AB. Huh. Okay.
Is that someone disconnecting?
No, that's an email. Slightly different tones. Yeah. Okay, so A, B, C, D. I may even be able to keep a 1, 2, 3, because you know they think they know better. Three. What?
Okay.
2 goes into 18 9 times, right? And then the y's go away?
Okay. I was like, wait, what? I thought we were still reading first and then.
No. Simplify first.
Okay.
It makes it so much easier. 40x y cubed over 8x leaves me with 5y cubed. Sorry, the square root of 5y cubed. So it's going to be y, 5 square root of, oh, why isn't an equal sign in there? Let me try that again. Y square root of 5y. Yeah, on the divide ones, Harrison, it's so much easier just to go ahead and divide it first. Yeah. So this will be the cubed root of 96, a to the 4th, b squared, over 12. No, I don't think so.
In this class, but at some point.
I'm sure you did, because everything that you've learned in this class so far has been a repeat of Sec 1, 2, or 3.
Did we do this in Sec 3?
No.
Okay, then I don't, yeah, we got that.
So this is the square root of 8 a squared b. So this should be 2, oh, this is the cubed root. 2 cubed root of a squared b. You're getting them right? Nice. And then this one I wrote as 1/3 square root of 75 ab over the square root of 3. Oh, I don't know why I put square root of 3, sorry. It should just be 3. Over 3 is going to equal the square root of 25 ab over 3, or 5 square root of ab over 3. Yeah, that's it. What? Are you sure? Okay. Okay, and the last one we're going to do is, so we are going to, and you probably learned how to do this, and I don't know which one you learned how to do this in. Rationalize the denominator. So this is it's so stupid, and I know that I don't remember if you learned it from me or not, but one of the biggest debates in the math world right now is if you can have a square root in the denominator. Really stupid, right? Half the people say, yeah, you can, and half the people say, no, you can't, because you never used to be able to. You never could have a square root in the denominator. Okay, so we're going to show you, because in college they're probably going to tell you, no, you can't have a square root in the denominator. Okay, so we're going to show you how to get rid of it. It's really easy. Okay, it is. It's really easy. So I am going to rewrite this. I have to figure out how I want to do it. I'm going to rewrite this as the square root of 7 over the square root of 2, right? So how do I get rid of a square root in the denominator? It's really simple. I'm going to multiply by 1. It's going to be a very special one, but I'm going to write, if I multiply by 1, it doesn't change the value of the expression. It just changes the look of it, right? So I'm going to multiply by the square root of 2 over the square root of 2. That's 1, right? I'm just going to take the square root that's in the denominator and make it a 1 and multiply by both the top and the bottom. So that gives me the square root of 14 in the top over, what's my denominator going to be? What's the square root of 4, which is 2. And that's why you multiply by the same square root that's in the denominator, because then it gets rid of the square root. That's called rationalizing the denominator. Okay, we're going to do it a couple more times. Thank goodness this one's already divided up for me. So on this one, I'm going to multiply by the square root of 3 over the square root of 3. Because the square, I only need to multiply by the square root, not the whole thing, just what's under the square root. So then I get 2 square root of 15 all over 7 square root of 9, right? So that becomes 2 square root of 15 over, what's the square root of 9? Times 7? 21. Done. Questions? Oh, I don't even have you guys all up here so I can see you guys. Or see your names. Okay. And I think. Okay. And then, let's see. Okay, so now we're going to do a cubed root. That means I need 3 of the same thing underneath, right? So I'm going to rewrite this one as the cubed root of 2 over the cubed root of 3 squared. Is that not right? 3 squared is 9. So what do I need to add to the denominator to get 3 3's down there? 1 3. So I'm going to multiply by the cubed root of 3 over the cubed root of 3. So that will give me the cubed root of 6 over the cubed root of 3 cubed. So cubed root of 6 over 3. Done. So now you guys are going to try it, and I think that there's only 3 problems. Beautiful. Okay, go for it. So here we go. So for A, I'm going to multiply by square root of 7 over square root of 7, and we get 3 square root of 35 over 14. And then for B, I'm going to multiply by the cubed root of 2 over the cubed root of 2, because 4 is 2 squared, right? So we get the cubed root of 10 over 2. And then C is a little bit harder. So I'm going to multiply by the cubed root of 25c squared over the cubed root of 25c squared, right? Because I need 2 more 5s to give me 3 5s in the denominator and 2 more c's to give me 3 c's in the denominator. So that gives me the cubed root of 75ac squared all over 5c. Does that make sense? Or is it, yeah, we're good? Any questions, anybody? Anybody at home have any questions? Okay, so you have a Delta Math today. I don't know how many questions.